Hello everyone, this is the second part of my modulation demonstration video. In this video, I am going to demodulate the modulated signal. So quickly and briefly I am going to explain the whole thing. So basically I am having two signals, one carrier signal, the carrier signal, and one modulating signal. The modulating signal is 50 Hz signal. I am multiplying a 50 Hz signal with a carrier signal. So presently here, as you can see, this is my oscillator generating 48 kHz signal. This is the carrier signal generator. And here is the 50 Hz modulating signal generator. So these two signals are multiplied in this circuit. The modulating signal is fed here in front in this transistor base, and when it is mixed, it is generating a frequency based on the multiplication of two frequencies. So as we have seen in the previous video, we got a frequency of 24 kHz. So now I am going to demonstrate how the circuit exactly works. As you can see here, at the output of the oscillator, I have connected a transformer. The secondary of the transformer is connected to multimeters. So basically, in this part of the circuit, there is a modulation taking place. So currently, as you can see here, there is no modulating signal. There is no modulating signal. So at the output of the circuit, how much I am getting? I am getting a frequency of 48 kHz. You can see I am getting a frequency of 48 kHz. There is no modulating signal of 50 Hz. As you can see, there is no modulating signal of 50 Hz. Now I have switched on the modulating signal of 50 Hz from Arduino Uno pin number 13. So it is fed to this transistor. You can see here, this transistor base, it is fed and modulation is taking place. And you can see here, there is a frequency of 24 kHz. So this frequency is no more 48 kHz. There is a multiplication and we are getting a frequency of 24 kHz. So why we are getting 24 kHz? Let's discuss the theory. So as you can see here, this is the carrier generator, and here we are feeding 50 Hz signal from Arduino Uno. So when we are feeding here 50 Hz signal, at the output we are getting a modulated signal. This modulated signal is fed to this transformer. You can see. So what's basically happening? Basically, when we are giving a 50 Hz signal, both the signals are multiplied and we are getting a waveform like this. So this is the zero reference of the waveform and it is coming like this. The waveform is coming like this. So we have seen before, the modulation theory says when two signals are multiplied, the resultant signal will have three components. You can see the resultant signal will have three components, but this depends on what are the amplitudes of these signals. So in this present case, we are not having AC cos phi component and we are not having a negative component of the signal. You can see we have only one component. You can see there is no negative component of the signal and there is no amplitude lifted signal, like there is no zero line here and it is not lifted. So there is no AC cos phi component present, and here there is no another component present. So only one component is present. So as you can see here, the formula says it is a division of 2. So whatever is the frequency divided by 2. So 48 divided by 2 is how much kilohertz? 24 kilohertz. 48 by 2 is 24 kilohertz, and we are getting a frequency of 24 kilohertz. Now we need to demodulate this signal. So as you can see here, this is the demodulator. This is a Schottky diode, high frequency diode. Here is a capacitor and here is the resistor. So this is a RC demodulator. As you can see, this is the RC demodulator and this is the output of the demodulator. So as you can see here on the demodulator, how much we are getting? We are getting 2.9 volts AC and we are getting 50 Hz frequency. See, we are getting 50 Hz frequency back. From here, we were feeding 50 Hz and now at the output, after demodulation, we are getting 50 Hz frequency back. So this is how modulation is taking place and the modulating signal is filtered out using a concept of envelope detector is used. As you can see here, So this is an envelope detector, basically the diode, the capacitor and the resistor. So we can see here I am getting a frequency of 50 Hz. The modulating signal is coming back after demodulation. So this is the demodulator, and here on the circuit you can see this is my demodulator, the Schottky diode, the capacitor and the resistor, and here comes the load. So finally here we are getting 50 Hz. We have injected here 50 Hz. We are getting back 50 Hz here. So this is how modulation and demodulation is working. Thanks a lot. Thanks for watching.